This particular video is going to introduce you to the first form of what we call the chi-square test here in Chapter 14. These tests are hypothesis tests, just like the tests for one mean, for two means, for one proportion or two proportions. They're calculated in a slightly different way, but thankfully for us, they follow pretty much all the same logic. They're just useful in a series of different types of circumstances. So my goal here is to help give you a chance to see where a test like this might be useful, and then actually have you collect some data to perform a specific test. And thankfully, we're going to base that data on M&Ms. Okay, so if you'll turn in your book to page 834, there you're going to find the activity. And you probably want to stop the video and read the description of the M&M's activity up to step 1. And start the video when you're ready again. So assuming that you've read this, you probably saw that in the case of the M&M's distribution, we are told that when they make M&M's, they make 13% of the distribution brown. They make another 13% red. They make 14% yellow. 16% are green. 20% is orange. And 24% is blue. So what we want to see here is we want to try to say, well, how could we possibly test a randomly chosen bag of M&Ms to see if it matches this distribution? Well, you can imagine, under the logic that you've already learned, that we could, for example, isolate one of the colors. Let's go ahead and say, oh, I don't know, green. Now, if we wanted to test the hypothesis that we actually have green at 16%, you can imagine that we would test a null hypothesis that the proportion of greens in a particular sample representing the entire population would be equal to 0.16. And the alternative hypothesis we would probably use, unless we had some thought that it was less than 0.16 or more, we would probably test the two-sided alternative that the proportion was not equal to 0.16. The trouble is, that only tells us about green. And if green is not equal to 0.16, it's likely one of the other colors is off. We would have no idea which color, or if it was all colors or just one color. We would have to test every single one of these separately to see if they had the right proportion or not. And I don't think you would have to go through that process once to be convinced that that's not very efficient. What we really need here is we need a test that can look at the distribution as a whole and say, how do all of the colors match the expected distribution? That's exactly what the chi-square test is going to do for us when we apply what we call the goodness of fit test, which is a very awkward name grammatically, but that's just the name of the test, because it's literally going to say how good is the fit between a particular set of sample data and what we expect. So we're going to be measuring that difference. And of course, as you know, there's going to be variability. So the chi-square statistic is going to try to say how likely is our sample in light of our assumption, which of course is going to be that our M&Ms really do match this distribution. So let's walk through the steps that you're going to perform, and then you'll have a chance to do them. In step 1, you're simply going to count your M&Ms of each color. Please make sure you don't eat any until you've counted them all. And then after you count them, I don't care what you do with them, eat as many as you like. Notice that you're going to make a table of your counts. And you're going to be careful to think about how you're going to fill this out. So you're going to have a table that's going to have the colors across the top. And I'm not going to write all of them, but for example, you're going to have brown, and you're going to have yellow, and you keep on going from there, okay? You're also going to have a row here where you're going to put the observed count O. We're going to call that O, and you're going to put what you observe. So if you observe 10 browns and 3 yellows or whatever it might be. That's what you're going to put. The other row that you're going to have here is what we call the expected count. In other words, for this particular bag, how many browns and yellows did you expect? Now remember that 13% of the bag is expected to be brown, 14% is expected to be yellow. So you're going to need to know the total number of M&Ms in your bag. And just to make that easy, let's just say you had 100 M&Ms in your bag. If that were the case, we would expect 13 of them to be brown, because we would take 13% of our total. In that case, it would be 100, and that would mean we'd expect 13. 14% of 100 would be expected to be 14. So keep in mind that this expected row is one you're going to have to calculate. Beneath that, once you have calculated those, notice that you're going to calculate what we call the chi-square statistic for each color. And that's simply going to be this formula right here. Whatever you have in the O column or the O row minus what you have in the expected row squared divided by the expected row. So in this particular case, O minus E would be -3. -3 squared would be 9 divided by 13. And you would want to convert that to a decimal. And you would repeat that process for the entire thing. Okay? So at this point, you've got this whole last row. Okay? You add up all of these values to get what we call the chi-square statistic. It's the sum of all the statistics you've already done. And that's going to be what we're going to use later tomorrow to actually perform the test. Okay? Now, you're going to repeat this process. You're each going to have your own sample, and then you're going to repeat the process as a class. So you should end up with 2 tables like this, one that looks like this one, and one that represents the data for the entire class. And then we're going to use that information a little bit later. I'd also like you just to formulate a hypothesis of your own, which is how well you think this information is going to match the expected distribution, both for your own data and also for the class. So kind of try to develop a theory that then we can test tomorrow. Once you're done with your data collection, then what you can do is you can take a look at example 14.1 and 14.2. Those basically start on page 836 and go up to page, about 840. And that will just walk you through what this process is going to look like for tomorrow. And then we will actually go through a complete chi-square test with the data that you have and also with the things that you've read about so you can see how it's going to work. Keep in mind we're going to be using that last table that you've had sitting around for a while in the back of your T distribution, so you'll get a chance to see what that table is going to do. But like I said, the good news is there's not any new logic here. We're still going to get a p-value. We're still going to evaluate a null hypothesis in light of that p-value. We're still going to have an alpha level, and all those things are going to still be the same. So we will talk about that tomorrow. So at this point, you just want to open up your M&Ms and get started counting.